so today, this afternoon, alright, it's like 12:30. I'm gonna talk about modules. So in the last couple of times I've done videos, I have tried to use like old vanilla JavaScript, like script imports, or I think I've npm installed, and I've still used script tags to pull them in. But today I'm gonna chat about making things into modules, and the overview of this is I don't want to go into import versus require quite yet, so I'm gonna do everything as just what we call commonjs modules. So a little bit of historical reference, I guess, is old school JavaScript used script tags. So, by the way, if you don't recognize this code, this is exactly where I left off in my other video about introduction to Redux. And it's not a ton of code. It's about 60, 70, 75 lines of code. I'm going to use this code base with its accompanying index file, which I will drop in here. We'll make a button real quick to fix that blue. I'm going to use that code base to show modules because it's a small code base already existing, and we can see how you can start modularizing things. So that's where we're going to start from. So if you're wondering where all this crappy code came from the previous video, haven't done anything to it since. So what we're going to go over is what's called commonjs. It's the require. So if you look at Node.js require, this is a lot of documentation about it, but it's the require function, which you've probably seen, and it's very similar to, but not the same as, imports. So this is going to be not about import because there are differences. That's ES6's module way, which Node is on the verge of supporting, I think. But we're going to talk about require. So first thing, let's get our app. I'm going to add a button real quick, because last time we had made a little Reduxy app, and we had to dispatch our own event to make it visible. And so I'm going to do that. I'll make a button that does that just so we have it, so we don't have to spam things into a console. So I'm going to make a button up at the top of the page called the show button. Put some text in here. Save that. Reload. Oh, we got a button, doesn't do anything. Let's grab that ID. Let's go make a listener down here. Add event listener on click. And we'll just grab that statement. And so we've made a very junky, quick, effective illuminate. And then subsequent calls don't do anything. Okay. So now we've got our totally functional suite application. And if you remember, or if you are not aware, I'll do a quick recap. What we had done was we had done Redux, which is vanilla JavaScript. So this is a little disorganized because I did it all in one file as I wrote it. And our state in this application is a tiny 2-reducer state object. One reducer just controls a Boolean. One reducer controls a messages slice of the state. And what it does is it takes whatever I type in here, and it will update the state with that verbiage or wordage. You can see the state changed. And this vowel count is also listening to the state and counting the message. So it's like a piece of derived state. And when you reload it, we had it start in a loading state, which was loading true with just like a big blue box, and then it fades out by changing that from true to false with a little CSS transition. So that's our sweet app that has total real-world business value. And now I'm just going to take that same code base with the one new button and turn it into modules. So modules, getting down to business. In the old days we had script tags, and it was very common to see just like script tags that just had JavaScript in them in the old days. You know, just do some business, get some business done. Those are great, those are neat, and those are terrible. They run, you know, they run as soon as they get hit. So where this script is in the markup is important. So for example, if I wrote a script tag up here, I wrote some code in it, I couldn't go grab the body or the like not the body, but like this H1 or this label. I couldn't do those up here because it's being executed like sequentially, like in order as it encounters it. So like that would blow up. But if you move the script tag down here, it would be fine. And that's bullshit. Why deal with that? That's just terrible. And like around the same time you could do, I mean, this script with the source tag's always been a thing, except back in the old days you would include source files that were just like in your project. Well, obviously, they don't have to be in your project, but that's what you do. And there was no NPM back then, so you never had node modules. You would literally go. This was how everybody basically worked back then. Was you would go find jQuery, you would choose a file, and you would just download this, drop it into your project, and you would say, source vendor jQuery, blah blah blah, and that's how you got your libraries. It's also sort of a not great way to organize things nowadays. But then I don't know if this is necessarily the way it came from, but commonjs was a thing. I think it was a thing independent of Node. And it was a way to define a module. So this was a thing. And Node was a thing that Node is backend to JavaScript if you're unaware. By the way, if you don't, you should always have Node installed on your system because it is really useful for JavaScript development, and all the build tools around the environment are using it. So I've said this in a previous video, but if you don't, you should probably go download Node and have it installed, some version of it. 8 is fine for most purposes, but you can stay up to date with it if you want. It's on 9. So CommonJS was a way to define modules. And modules were basically a way to do what you probably have seen in tons of other languages, which is imports, requiring, using, including, any of that kind of stuff. And I've gone over a little bit of this in another video, but that video did not get saved, so I might be repeating myself if you've seen it. So let's do, I have Node installed, so I can run Node and get a command line. And you can just do JavaScript in here. And it's a JavaScript REPL. Read, evaluate, print, loop, I think. So in this ecosystem of Node, there is a require function. What require does out of the box is you can pass it a string, which is a path to a module, a file, a JavaScript file, or a JSON file, or a Node file. But we're going to stick with JS for now, because that's the most important. You can give it a path. You don't have to say JS, by the way. It'll just handle that. And it will go grab that file for you and bring it in, so to speak. And we're going to go into that in a little bit of detail. So let's, right now we're in the Redux Intro folder, which is where we are up here. So what I'm going to do is forget the little web app for now. Let's make a little module, and let's play around with how modules work first, and then we'll go into applying that idea to the web app. So ignore the rest of these files, really. These are going to kind of live in their own little, for their own little purpose right now. So let's make a module. So modules, what require kind of does. And there's actual implementation, obviously. So this is my explain like I'm 5 explanation of what it does. Require follows this path, goes to that file, and it basically evaluates and like runs that file. It just like executes it, and it goes and the thing it does is it injects. Trying to think if I'm using the right term here. It basically injects this object called module with a field on it called exports. So whatever's in your file, so this is sort of like meta information. Whatever's in your file, you could have like some JavaScript, right? Let's require this file. And let's just make it X for now. Look at X. X is just an object. There is nothing on X. So nothing broke, right? Okay, that's good. That's useful, Eric. Thanks, you fucking idiot. Let's make it do something so we can know it's actually using our code. Now, I need to exit and re-enter, and I'll explain that in a minute as well. Look at that. Look at that. We did something. Something happened. Let me add some more words to this. So I'm going to do that. First of all, before I restart, before I cancel out of Node here to do this again, let's see what happens if I just try and require it again right now. Nothing happened. Didn't see my console log. Now if I exit Node, I go back in, now I see my new log. So that's one thing, I guess, to know about require. It caches modules. So if you include something, like in here, in this case, we're including my file, it only actually goes and like gets it and runs it, that file, one time, and then for the rest of like the situation, the current instance of Node or whatever, if you require it again, you get what it gave you the first time. It's cached. Like you don't re-execute all that shit. And we'll see some other implications of that in a minute. So we got this thing, and we can require it, which right now is just basically running it, right? And for some reason, it's giving us back an empty object. Now here's where this module exports comes in. I told you like the require basically like injects this object. So this module.exports is available here. It's available in your file, and if you set anything on it, it becomes what require returns. So it's basically like your module is like a big function that gets called and gets handed in module.exports, and if you do anything to it at the end of your file when it's done executing or running it and evaluating the whole thing, module.exports is what you will get handed back. So let's say module.exports equals foo. So I said foo is 5. I'm going to complain about foo, and then I'm going to set module.exports equal to it. So I'm going to close out again. There's a way to like clear the cache. I can't remember offhand, but I'm not going to get into that. I think it's just like required clear cache or some shit. Anyway, so now let's say x equals require. We see our console log. By the way, it says undefined because whenever you do a command in a REPL, it'll automatically log out the return of the line of code you just wrote. And the line of code I just wrote was an assignment, and assignments don't have a return. So just ignore this undefined. If you ever do like an assignment like, you know, let bar equal bar or bar, it's going to be undefined. But if I said like something that returns something, then it would print that out. Anyway, let's look at x. Like that. I said x, it evaluates it. X is 5. That is what we set this equal to. So if we set this equal to the string, hello world, relaunch, say x equals that, there's our log again, so we know it ran, x is hello world. And so that's what module.exports is for you when you're writing some code in a file that you want to be consumed as a module. And a lot of times what you'll see is people will make this into an object that has things on it. Like say we're writing a module that does some stuff and we want to say, well, I want it to actually, like if we were writing Lodash as one big module, if you haven't seen Lodash, it is a sort of like classic utility library in the JavaScript world, has all this stuff on it. You could imagine Lodash has like a module that's just like, well, here's chunk, it does stuff. Here's compact, it does stuff as well. And then let's pretend like we wrote the rest of it. Let's go back in and let's say let x equal require, and look at x. There you go. Now you can call x.chunk. It doesn't do anything because we didn't write it, but you can call x.compact or just look at it. It's a function. So this is a way that you can sort of like build self-contained modules with stuff in them. And the stuff you put in here can be like remembered. So these modules are sort of their own little space. So let's say we have one that says, let's record. It's going to be a function that takes a string. And then what it's going to do is we're going to record a message into the module. We're going to say it starts out as nothing. And then when we record, we will set it equal to the string. And then when we play back, we will just return the message. So what this does is when require gets executed, it's going to evaluate this. I can get rid of this, sorry. It's going to evaluate this thing. It's handing in module exports. It's going to say, all right, inside this scope, there is a variable called message. And then we're going to put this on exports. We're going to give it an object that's got two fields, record and playback. This record is a function that takes a string. I just named it string. It could be whatever, right? This isn't a typed system here, people. Could be, but we'll get into that later. It's going to take a new message, and message is this. And it's available because in JavaScript, whenever you create a new scope, a new function, things a level above it are available. So we're basically like saving this new message off by assigning it to message. And then playback, when it's invoked, it's a function, and so it has access to things in the scope above it. It's going to just return it. And again, this is a fat arrow, so this is the exact same. Never know if people are new to fat arrows and stuff, but it's the exact same as this. Fat arrows, if they only have one line, they also return that line, so it's just shorthand. So let's save that. Let's bring it in. We can call it, we're just calling it X right now. X has record and playback. I can say record. Well, actually, let's do playback first. Empty string. And then let's record a new message. Classic. Record hello world. Playback. So you can see, this is just illustrating like you can have things inside the scope of the module that can persist and like be recorded or like, hang around. Now that's not always the best thing to do, but you use at your discretion. Suffice to say, this module sort of like lives on its own. It's like its own little its own little scope, its own little block of the code that's hanging out. And if you ever require again, by the way, you will get the same one. So if I require this again in the same like instance here, the same runtime, whatever you want to call it, and we do a playback, we get hello world because it doesn't reevaluate, it doesn't rerun this code the second time you require it. It gives you back this object cached. So when this got required once, you got back this object, and then that object gets put into the require cache. So somewhere in Node's memory, there's like this like require mappy thingy, and it says, well, I was told to go get my file, and I got back. Let's pretend this is called A. I got back this object, and that's what I gave them back. That's what we gave them back right here. Now if somebody else requires the second time, it's going to look in the map and say, I've already got that, and so I'm just going to hand them back this exact same object, so they get the same object back. So we should be able to see they are the exact same object, and that's triple equals, which means it's a referential check. These are the exact same object in memory. So that's important to know. That's also nice because you can require this file tons of times. Tons of people might want to use this module. By people, I mean components or files or spots in your code might want to use the same module. You do not incur the cost of evaluating the module every time. And the double-edged sword to that is, like if message, in this case, if message got recorded by some first consumer, every consumer after that, every file after that that required it, is going to get the same message by playback. And that could be intentional, or it could be not. If you want it to be sort of like a singleton where everybody shares the same thing, that's good. If you don't want it to, we could do that. So let's say we want this module to record and playback, but we want each consumer who requires it to get their own, that records and plays back only what they want. All right, well, we can do that a couple ways. One way would be, instead of returning just like a single object, let's return a function that creates a new object, and let's move message into here. I don't know where that went. There we go. So take a look at this, and let's see if what I just wrote actually does what I said it does, because that is always the real test. So let's bring it in as x again. So now x is a function, and it's almost like a constructor right now. I've made it like basically like an instantiator. So let's say, actually let me redo this. I don't want to call it x. Let's call it create recorder. That's really what it's about to do. Now let's say x equals create recorder. Now x looks the exact same. We should be in the same situation we were. Starts out empty. Record hello world. X.playback. Hello world. Now for y, you don't have to require. We have that reference to create recorder because that is this function. And now if we create a new one, y looks like that. Y.playback. Empty, because it's got its own message. So every time you run this function, it is creating like a new scope in here. There's like a new scope because you're inside of a function. So message is a different message than the first time you called this function. Every time you call this function, it has its own internal message variable, and then it returns this object. Because these are functions, they have their own scope, and by that I mean they basically, saying they have like access to this scope, like this function has access to this scope. So like shorthand, that means this function can access any variable in the scope above it. The other point I was going to make, basically every time you create a function, it remembers, that's like the term I want to use, it remembers all the variables that are available just above it. And that's why when we call record, it can reference message here, because record, this function, is created right here, so it remembers the scope, the function scope above it. It's a little loose. I hope that's somewhat illustrative. But what we're doing is we're calling this function every time we call create recorder, and this creates a new scope because it's being invoked. That scope has its own copy of message each time, and so they're their own, they're totally different copies of what's going on here. Totally different scopes, totally different instances, whatever you want to say. So that's one way to create to sort of like get that functionality, but have it be separate. So that everybody who requires, so that require, by the way, there's still a require map going on here. It's still, something is still like cached. It's just that now that require map, and this is not exactly how it is. Again, this is just me trying to like illustrate it, draw it out. The require map now says, oh, my file returns this function. We'll call it A. It's not, who knows what the hell its name is. And that is just a reference to this thing, which is a reference. So there's only one function. It's just that every time you invoke it, it creates a new variable and two new functions for you. So in this situation, a.record or x.record is a function. It does not equal y.record. Even they are not the same function. They're both their own functions that get created every time you invoke this. Now, create recorder is always the same function. It's a single function. It's just it generates more functions. So like, well, that's stupid. I was about to literally do that. But what it creates, x and y, are not equal because it is returning two different objects with their own functions. I feel like I said that 35 times, so I'm going to stop now. Okay, so those are two different ways to. I'll put the old way down here. So if I just moved this out and I returned only this part of it, you can see that like this was like singleton mode, and this is like I guess the opposite is like request, not singleton. I don't remember. Anyway, each their own mode. Yeah. I'll maybe leave this up there for example. Okay, so that's kind of in a nutshell require. I've mentioned in a previous one, there is a little bit of nuance to how you write this. If I wrote require my file, the ecosystem is set up that the logic is if there's not a relative path like that, it will go look inside first the standard libraries of Node, of which there are some, one being file system. That's the file system library. It's a lot of shit. If it doesn't find it there, it will go look in Node modules. And so a good example right now is, because we're in this directory, and this directory does have a Node modules, if I require Redux, it will say, well, I don't have a standard library called Redux, but it will bring in the one that's in Node modules because it sees it there. And so just like we were using Node modules in our index by bringing it in actually from Cloudflare, we can get pretty much probably the same file, or almost the same file, by doing this. So we could say, Redux equals that. And then we have access to Redux, just like we used it in our previous application. Right down here. So like you could do the same stuff that we did in the browser, you could do that same stuff here. And actually, I can't require this whole module in because it's looking for document. That's a big difference in mentality. When you're messing with Node stuff, this is not a browser. There's no document. There's no window. This is not the browser world. This is just JavaScript running by itself. And then the third situation for require is the one we've been doing. If you give it a relative path, it will not look in the standard libraries. It will not look in Node modules. It will start from the directory you're in. And right now, we are in, oh my god, I can't type. We're in Redux Intro, which is this directory. And so when I do a relative directory like that, we get the file that we wanted, which was, my file. And you can go any path you want to type here. I could actually go up out of the directory and grab files. Not a great pattern. But depending on where this require statement is written, that's the relativity. So let's step into a bundler. Now, bundlers are a big topic, and I'm probably not going to go over everything because there's way too fucking much. But how require has worked its way into modern JavaScript is that we started using bundlers, the most famous of which currently is Webpack. we start using bundlers to write code like we do in Node. So that you have sort of common conventions, common patterns. And what that means is we basically have introduced a compiler step, so to speak, to JavaScript. JavaScript is not a compiled language; it's an interpreted language, which means the browser basically just reads it and runs it at the same time. It's glossing over a lot of technical stuff, but that's basically what it does. Webpack, and there's some other ones out there. Parcel is a newer one that's really cool, and I actually might use it for this because I like that it's way less configuration than Webpack. Webpack is still like by far the biggest one, and it's insanely powerful and has a ton of customization. It's sort of like the enterprisey bundler. It's got a lot of shit to it. The newest one is supposed to be less configuration-y. I actually haven't tried it yet because at work we are still on 3 and shifting is not a priority right now. There's also, to a lesser extent, there is Rollup. And this is used a lot by people publishing Node modules. Oh, that's not good. I don't know why Rollup's website is down. That seems terrible. Anyway, Rollup is another one. So what these all do, and it's like, oh, what the fuck, why are there so many? Do I have to learn them all? Someday maybe. But anyway, the gist of what they all do is that you execute them, they will run against your JavaScript code. Typically you tell them where to start, like start at main.js, index.js, app.js, whatever. They will start crawling your code, and they will encounter require statements, and they will follow them, and they will keep following them, and then they will build all of this code together into one file for you. And this allows you to build your front-end code like you would build Node code, very broken up into little pieces. Everything can live where it's best logically suited, and you come out of it with one JS file. Now there's a lot more customization that you can do to break that up into smaller JS files, because sometimes you don't want everything in one big one. But the point is you can start to code like you do with Node, and like most languages do with sort of compartmentalizing things into their places. You don't have to code in one giant file like this idiot who wrote this code. What a tool. I'm going to start using Parcel because it really is good about having like very little to no configuration. So I'm going to use npm because that's just very normal nowadays. So I'm going to install, I think I already have it installed actually. So I'm going to install the node, or the bundle parcel bundler at the top level. -G just means global, which means it'll give you access to running the command just from your command line. I'm on Windows, so it's going to take longer than it should, which is great. Debbing on Windows is not the best idea, by the way, but kudos for trying, I guess. Alright, great. Why is this taking so long? I feel like I could have copy-pasted their source code by now. So what Parcel does, and what we're going to see it do, Parcel, you can normally just point at an HTML file, like our index that we're about to do, and it will actually go through and look for script tags and link tags for CSS, and it will crawl them in a kind of like a very organic way. It will just crawl them from there. So in Webpack it's a little bit more configgy in that you normally have to like tell it like what JS file, and then you will write a script tag to include the final file yourself. Parcel sort of like skips those steps. It's just like, look, if you put something like this, like a script main, I will just dive into main, and I will start following require statements, and I will like dump out a file, and I will even run a server for you so that you can hit it and start using it. So it just makes a bunch of assumptions and runs crap for you, which is nice. Conventions are sometimes very nice to have. So let's try and get this running. Let's do Parcel against, whoopsie, typed in the wrong spot. Let's do Parcel. I think I can just run Parcel. Okay, I was just checking to see if I had the right executable name. I guess I did. So I tried to run it once, with no arguments. I just said parcel go. And I'm assuming index.html is a pretty strong convention. It probably just grabbed right onto that, and it immediately ran into a problem. So that's great. So it did not like object destructuring. So that's a thing. Object destructuring is a newer thing that's not actually like standardized in the language yet, as far as I know. I think it's like almost. So this is where we're going to have to get into Babel, which I really didn't want to, but that's fine. So Babel is a transpiler. Suffice to say, the short of that is, if you're not aware, Babel basically lets you write the newest forms of JavaScript. Oftentimes things that the community hasn't even agreed should be in the damn language yet. And it's called transpiling because it basically turns JavaScript into JavaScript. So Babel's very, very cool. It's probably going to be around forever at this point because it's kind of amazing. Yeah, you basically get to write the newest way of JavaScript, and it turns it into, there's a good example, it turns it into JavaScript that you can expect to work anywhere. So, like, you can write new JavaScript, and it runs in IE11, which is still around for some fucking reason. So, Parcel, out of the box, is just going to try and, like, follow your requires, put all your JavaScript together for you. But right now, I have written my JavaScript. So, step back one. I ran Parcel. It saw the index. It probably went in here. It saw a script tag that it didn't need to care about. It saw a script tag that was local, so it went into main, and it tried to compile main together, looking for requires, parsing the JavaScript. And it ran into this and was like, this is some shit, I don't know what the fuck you're doing. So we just need to explain to it that we have some newfangled bullshit in here. And Parcel is set up automatically that if you have a .babelrc file, it will use Babel for you. So normally with Babel, you run Babel, or something runs Babel for you, and Babel looks at your JavaScript and says, that's some newfangled bullshit, and it turns it into old-fangled bullshit that all the browsers can run. So what we're going to do is we're going to look for Babel object destructuring. There we go, object rest spread transform. So this is the thing we're trying to use. And here is the Babel RC thing. And what this is Babel RC is basically like a configuration for Babel. So Babel is a big tool that can do tons of stuff, but it's based on plugins and configuration. So Babel by itself doesn't do shit. Babel is just like the engine. And you plug in the pieces that you want so that it's not a gigantic bloated engine, unless you make it that way. So right now I'm just saying, Babel, I want you to transpile some shit, and the only thing I need you to transpile right now, so far, we'll get to more, is transforming object rest spread. Now I need to have this stuff installed in my project. So we're getting a little bit carried away, I feel already. But so what I'm going to do is I'm going to say locally npm install Babel. I think it's Babel CLI actually. Let's see what Babel says. Did I look up Babel? So let's look up npm Babel. I just can't remember if it's CLI or just Babel. It's probably CLI. Yeah, it's Babel CLI and Babel, or Babel core if you want it locally. So we'll try that. Let's do Babel core, and I know I want this plugin for the Babel core. And they all follow this sort of naming thing. Like this is a plugin, so it's a Babel plugin, name of plugin. Let's install both those, and we'll rerun Parcel. And Parcel is set up to automatically recognize, like, oh hey, there is a Babel RC. This person wants me to use Babel. So let's see what error I run into next, because I've probably gotten ahead of myself. Okay, so it claims to be totally cool with this shit. Let's see if it is totally cool with it. So it runs a server for you. And let's go to localhost 1234. That's our fucking web app. That's pretty neat. So it's pretty minimal. That's good. It tried to find a favorite icon, so don't worry about that. everything's still good to go. Bam. All right, cool. So what happened there was ran Parcel. Parcel saw that we had a Babel RC, which means I intend to use Babel. I installed, if you look at the, we don't even have a package JSON, that's funny. So I installed Babel, so we have, where the hell? No, sorry. Ooh, there we go. So my node modules is a lot bigger because we have a bunch of Babel stuff in there. And actually, at this point, because I've installed a couple things, I'm going to do an npm init just to get a package JSON. -y just means I'm fine with all your defaults. I don't give a shit. And so these are the three things over the course of this that we've installed. We've installed Redux, the Babel core, and the Babel plugin. Now, if we didn't install these, if we just had a Babel RC, Parcel would blow up. Parcel would crap itself, and we can see that if you want. I will uninstall Babel core, uninstall Babel plugin transform object rest spread. Did not have to copy paste, so it took longer. Now if I try to run Parcel, it should crap itself and say like you're missing some Babel shit. Oh god, it didn't. But it's not actually working. Cool. Oh, you know why? Parcel does heavy caching. That's sort of one of the things that makes it fast. So let's disable, well, not disable, let's kill the cache and have it re-go. It actually already had the artifacts built, and that's why we were kind of cheating there. So anyway, so a fresh run of Parcel, if I had failed to install the right things, you can see this is going to say unknown plugin, transform specified, blah, blah, blah. Basically, this is the important part. Unknown plugin. So we have a Babel RC that says we need this plugin. It says, I don't know where that plugin is. So it will error and tell you so. So let me put those back in. And this is just tracking. We installed these, so these are now dependencies of our project, which means if I delete this whole folder and I run npm install without an argument, it will install these three things. All right, so let's run Parcel again. So right now we're not even using require, right? Right now all we've done is we have a script source, and Parcel as a tool is bringing that in for us, which is nice. But we're not even using require actually yet. Am I going to the wrong damn page, by the way? How have I lost track of this? No, God damn it, you son of a bitch. That's weird. So, what did I fuck up? That's the real question here. Is it because it's cached again? That would be important. Let's try and bust the cache. That seems silly. So so now I'm just trying to figure out why their cache is being stupid. I mean, I can just go delete it again. I just don't want to have to do that. Huh. That's weird. Alright, well, I'll delete the cache. This is not the way they intended you to use Parcel, I guess. Run again. Building, building, building. What am I doing wrong? This was working a moment ago. We've returned to the same situation. Let's take a look. I'm not sure why that's breaking. Let's try knocking everything out of the way. So delete cache. It also has a dist where it builds resources. I'm gonna clear that out too. So fresh, clean, Parcel run. So fresh. What in the hell? Alright, I don't trust this anymore. I'm gonna bet this is a Windows problem. Let me take a look at my task manager. I'm gonna take a guess. No, I don't see anything running. What if I kill this? So that should definitely be a 404 now. And let me rerun my console. Get back into Redux. I'm going to remove the cache, remove dist. Good. And then Parcel. What the fuck? Yeah, I've totally lost the server somehow. Confused. Well, this is a terrible example. So looking at the requests, we are missing localhost can't be found. I am not sure what I did to break this. It was just working. What are Parcel's arguments? Let's take a look. You can override the port. We could try changing the port. Let's put it on 3000. Let's see if it's just a port issue. Nope. Let's try knocking the script tag out and just having like pretty much a very basic index. I actually wonder if I need to specify the index, because it was running it the first time, but is it now? What would stop my server from being reached? Let's see if I can specify the index HTML. Let's go back to 1, 2, 3, 4. Okay, so that's odd, I guess. Oh, you know what? I know what it was. All right, so there's a little node information. When you have a package JSON, they specify a field called main. Sometimes they'll specify other fields called module or JS next main or browser. These are fields that are intended to point towards the entry point of your application. So in this situation, I had done npm init a little while ago, and it created this file for me, and it used defaults for everything. It defaulted the main field, which was pointing to my JS file, which means I was serving basically no HTML, and so my server was just like, I don't know what you're trying to get at, because when you hit this raw, Parcel's probably trying to like point you toward an index, but it didn't load an index; it loaded a main.js file. So there's just a little disconnect there. So we can, knowing that, we can fix it that way. So what I will do is let's undo those things that I just fucked with. So we're back to basic, and then if you run it, we'll be back in the error state, right? Back in the error state. Now, let's just change the package to say this, and take a look at this. There you go. That's what it was. So that's my fault. I sort of did this like really quickly without paying attention. Now I wouldn't want my main to be specified as that stuff. For our purposes, I don't really give a shit about what this is. I'm going to leave it as the default. But what I'll do is from now on, I will specify index.html to Parcel, so that it knows like don't follow my default, don't follow the convention, which is package JSON if it's present. Do that because I said so. So okay. So we're in here. Don't need this anymore. We're done with that. Parcel is running. It's watching. So if you change files, it will rebuild, and you can just see the changes pretty quickly. So let's squeeze down a little bit here. So you can watch Parcel in the corner there. It will be updating as we screw around. It'll give you a little timer that tells you how often. And so now let's modularize our code. We got it entering fine. It's going into main, but we have a couple things we want to get rid of. So one is we have Redux coming in from Cloudflare. We don't need to do that. We don't need the user to have to go get it. We could bring it in. So if I remove this right now, hit save, our shit breaks, right? No Redux. No bueno. So let's go in here, and we can get Redux with a require in here now. Say const Redux equals require Redux, because we npm installed Redux. So hit save on this, and we're back to working. Everything's still good. So what that's doing is Parcel is a bundler, and most of the things I say are going to pertain to Parcel, Webpack, or I mean any of the bundlers really. At their base level, the one thing they do is follow requires for you. So in this situation, I have main.js, so the trail here. Let me get this out of the way, simplify here. So the trail here for Parcels is going to hit index.html because we told it to. It goes through this, sees a bunch of shit, doesn't care, hits a script tag, and says, all right, that's a local script tag. I'm going to dive in there. Dives into main. First line says, oh, I got to require. It's Redux. Look in node modules. Found Redux. Grab the source for this thing. Bring it back. That's what this is equal to now. It's model of exports, if you will. Continue parsing. Just code. Everything looks good. Here's some newfangled bullshit, but I got Babel specified, so everything I'm reading, I'm Parcel in this, I don't know, novella I'm writing. Everything I'm reading, I'm actually running through Babel, and so I know how to transform that. So I turn that into some old-fangled bullshit. Good. No more requires. Things are just regular JavaScript from here on out. We're good to go. I pack that all up. I turn it into a single JS file. Looks real unreadable over here if you're trying to read this. And then that's what I put on the web page. So this is going to be really hard to read. I hope the font's big enough so you can see that it's hard to read, because it's got a bunch of stuff glued together. It's got the glue that glues all your shit together. So this is their require in the browser. You don't really need to read that ever unless you're, I don't know. I mean, you can. It doesn't hurt. But if you peek through here somewhere, you can spot pieces of our actual code. Oh, there's a lot of shit in here. But if we look for I don't know, if it's not minified, there's our section updater. So you can see that thing's in there. And it should look pretty close to the same because we wrote it in vanilla JavaScript. So that Babel would probably just leave this stuff alone because it doesn't need to be turned into anything. It doesn't need to be transpiled. But you can see right here, this is our newfangled bullshit. You can see this is what Babel turned it into. Babel defined an extends function that created a new object with everything from state and our new stuff. And that is basically the old-fangled transformation of this line. This line, that it old-fangled it, that'll run in whatever, i.e., I don't know how far it'll go back, actually. You can specify how far you want to go back in Babel. By default, I imagine it's probably doing IE 11 or some crap like that. Or it might be just doing actually ES5 compliant. But there are Babel plugins where you can say, I want to support, and you can specify, and you can say stuff like the newest Chrome, Firefox, and IE 11 up. And then it'll know what to transpile it into to fit your definition. So all of our code's there. It's not exactly the nicest looking because it's all getting compacted together and shit. But it's there, it's running, it's all stuffed together in this bundle. And that is what a bundler does. So now if we do more, we're not going to look at that code much more, by the way. I just wanted to point it out. We can start bundling our stuff a little bit more aggressively now for the sake of organization. So let's start screwing with that. So first off, I'm going to make a folder called source. It's a very common pattern. And I'm going to move these reducers out. I think they can live on their own. So let's say loading reducer. Oh, I can just type like the wind today. Loading reducer.js. I'm going to put this over here. So I want to get this loading reducer guy out of there because it's about, I guess one of the principles people talking about is cohesion and simplicity. I want things that are related to each other to be alone in a spot of logic so that I can read it more easily. So I'll move that guy over there. I'm not going to hit save yet because as soon as you hit save, Parcel will rerun and I mean, it's not a problem. Like, if I hit save right now, like, it's broken, right? Oh no, like, it's broke. Yeah, whatever, we'll fix it. So I move the loading reducer over, and I will move the action over as well, because that's going to be relevant to this guy's interests and related. And then in this, back in this file, leave all this stuff here for the moment, we need the loading reducer where? We need to know it by this point. So it's very common to have your requires up at the top. So I'm going to, the reducer on the right is not ready to be consumed yet. We haven't exported shit. That's just like a block of code. If we require that right now, it's not going to give us anything. We're going to get back that empty object like before. But I'm going to write over here how I want to consume it first, and then I'm going to fix it on the right. So in this file, this is our to-do fix thing. We need, somebody gives a shit about that action, so we need that. And then somebody gives a shit about the reducer. And then this actually should have been the constant. So we need both of those things. So one blunt way to do that is to say module.exports, learn to type, Eric. We can make it just like a map, an object, and we could just export them both. So that's a very just like straightforward way. So now, if I require this, it's actually a map. So what you can do is you can require, you can do this a couple ways. So we could like give it like a name, like that, and then if you, whenever you want to reference something that's inside of it, you could use dot notation and say like, oh, bring in loading done, and then when you want the reducer, say loading reducer stuff dot loading reducer, because we're exporting it, and then we got the other one down there. So there's that. So now we're back to working, and we got that stuff pulled out into a separate file. This is kind of a, this is one way, like this is a totally legitimate way. You can export things that you want to reference elsewhere, and then you can get this map back and reference them. Now if you want to not use like thing.thing all the time, you could also pull them out individually, and you could say loading reducer equals require that module dot loading reducer right away. And then you could do another line where you pull out loading done. And that way you can still just reference them without that whole namespace digging, which can get very verbose. So we could get rid of these. Use them just how we were before. The only difference is now we're bringing them in. And remember, this require doesn't cost you anything the second time. This is cached, so the first time, of course, it's going to run this code, quote unquote, run it, give you this object, and you're just peeling off a reference. And then the second time, you just get that object back immediately, and you're just peeling off the other reference. So you're not incurring some cost. And yep, we're still working. Cool. So that's one thing. Another way to do this in like shorthand with newfangled stuff, we're probably going to have to bring in a Babel plugin for this. If you, this is, I think this is referred to as destructuring object. Yeah, the other thing I called object destructuring, that's wrong. I was wrong. This is the spread operator on an object. What we're about to do is called object destructuring. You do this. Now, I'm pretty sure this is going to break because Babel. No, it's not. Good. Okay, sweet. So this is the same as the thing we just had a moment ago, just like truncated. So I'll try and get them, hold on, let me get them right next to each other so you can compare. This like declaration with curly braces equal to something that returns an object. Another example with simplified things. A5, B6. That's this is like that philosophy. This is that strategy. If you have an object and you want to pull fields out of it, you can do these curly braces, and it's called destructuring. You're basically pulling out the fields by name, and then you'd have access to them in the rest of the code. So you could see, you could like do that. So it's just sort of like a nice, concise shorthand to pull things out of objects. Very common nowadays in JavaScript land. So we're saying go get this module. That module gives us back an object, like a map. And then we're just saying I care about these two pieces. There could be more here. We just don't care about them. If I added like, you know, foo and bar over here, that's fine. There's no problem with that. We just don't care about them. We didn't peel them off. We didn't grab them out of that box of stuff. And that's it's a very normal way. So we got these make up our two things. We got that reducer pulled out. Now let's pull out the other reducer. It should be really straightforward. We've got the message reducer.js. Put that over there on the right, and then we'll do the same thing. Let's pull this up out of there. It's got the state and an action, so we'll take them both with it because they're sort of like cohesively related to that bit. And then let's say module.exports, and we'll export the action and the reducer. And I don't know if we actually need the initial state to be exposed. I don't think anybody else consumes it. And so this is sort of the idea, one of the start of the benefits of modularizing. So I think over here you get the benefit of, if I need to go fuck with the loading reducer, it's not buried in a bunch of code, right? That's like a clear reason to separate things. That's regardless of the module pattern. That's just like nice for different files in a project. So yeah, so at least in this situation you get the benefit of everything that's involved here is kind of in one spot. I can look at it, I can figure out what's going on. I could unit test this by bringing this file into like Jest or something very easily, and I could just like run this function and figure it out and test drive it. Over here, same benefit, but we also get the benefit of like this is now encapsulated, what you might do in OOP where you don't reveal, you have private methods. So this is basically private now. I cannot require this in and access this constant, or if it were not constant, I couldn't access it and change it. Like that's now internalized. So let's bring that in, and we'll say I want to pull out. This is kind of awkward about how you write this. You have to write the require first before you can get like autocomplete assistance, which is kind of annoying actually. One thing I've learned while writing Python, the fact that they write the requires flipped. They like import the file and then from it they declare what they want. That's a little bit easier for autocompletes, but whatever. We move on. So bring in message reducer, pull out the reducer and the action because we're going to use them in this file, and save all those. And something busted. Why is that? Well, that's because message reducer actually wants to use the action from the other reducer. Okay, so what we can do is we can do the same thing over here. We can just pull loading done from, or equal to, sorry, require, and pull it from right there. Now this requires a little bit different because it's from a different directory. So here, this file is at the top level, so we had to say, go into source, go to the loading reducer. This file is already in that folder, so its require says go into the nearby file. Now, when I mentioned that whole like caching thing before with the fake map, I deleted it. I guess I incorrectly I used the path you specified as the key that they use to cache it, and so in this situation you might think like, oh, this is going to rerun, so we're going to incur that cost twice. It doesn't actually require users like some resolve call to figure out the like I don't know if it figures out the absolute path or like a canonical path or something. Suffice to say, like this and this are going to return the same thing, and it's going to be cached. So again, don't worry about it. Require caches the calls. But now that message reducer has that reference, so we're getting a little bit of reuse out of it. We can share that definition. So if we ever changed what we wanted this to be, no problem. These both update and you're good to go. So we're back to a working state. Got some more modules. These are like our dumb handlers. I think I'm just going to leave those here. This is our Redux thingy. Here's some other pieces that actually I think could live elsewhere. So this message slice thing is really, you could argue like maybe that should be in the message reducer area. Maybe this shouldn't even be called message reducer. Maybe this should just be called like messages state management, messages.js, whatever. But this could live here too. Oop. And this is kind of a Reduxy thing you see sometimes in what they call the Dux pattern. Everything about this slice of state is here, including how to get to that piece of state. So I'm actually going to rename this get messages because that's what we call this slice of the state. I'm going to export it. And then over here, we can bring it in and let other people use it. And actually, why are we saying... Oh, because we have like messages dot message. That's great. Anyway, and the benefit here, by the way, it's like, why would you do this? You're just moving things around for fun now. Also, we'll fix this in 1 second. The reason I would move it here typically is just because like understanding that this is where this lives is basically what this whole block of code is concerned with. It's concerned with that piece of state, how that piece of state gets updated, what it starts out as, and where it lives on the store. Now, for this function is broken right now because it has a reference to the store, to its state. What I'm actually going to do is I'm just going to hoist this up and say, tell me what the state is, and then I will tell you how to get messages off the state. And so over here, what I would say is pass in the state to me, the whole state, the high-level state, and I will tell you how to get down to that part. And this is sort of like an encapsulating a law of Demeter type reasoning. If I want to change where this thing lives on the state, I want to hide that from other people. This is a small gain. It's not the best, the sickest of gains. It's not that big a deal. But that's sort of the justification, is like, I want to hide that. I don't want anybody else to be concerned with knowing that this reducer lives on and controls this part of the state. They can not care about that. In fact, we could even hide the message entirely, and we could say, let's just call this get message, just straight up, and return all the way down. We'll drill all the way down and hide the detail there, and just get rid of this. And now we've basically made, oh, sorry, I renamed it. We've basically made, who still has a reference to multiple, oh, I didn't save this. There we go. We basically have made what's called a selector now. You have this selector that people can consume that just says, I'm going to get you a message. All you got to tell me is just tell me the whole state, the whole damn state. You don't have to know anything about it. The high-level, entire goddamn state object. I will give you what I tell you I give you, which is a message. And so this area that's in charge of maintaining that state, updating that state, setting that state up in the first place, it defines this thing because it is the best place, the most likely candidate who would know where to get that from. And so it knows how to crawl down the state object and get you back what you're asking for. It's just the idea of keep things as dumb as shit. Keep things very dumb. Val updater, does it need to know that there's a messages blob of data on the state and that it has a field called messages? No. It can just know, hey, I give a shit about this thing that we're all calling like a message or a phrase, whatever you want to call it. Go get it for me. End of story. And then if we ever want to change this stuff, if I ever say, like, you know what, message is stupid, I'm using that word too much. Why don't we call it, like, text? Why don't we call it phrase? I can change it right here and say, we're going to call this phrase. You guys are now updating phrase on this slice of state. Save that, and our app is still Totally functional. I didn't have to go update this. I didn't have to go update this. So those things are pulled out. These things we could move these for funsies into like a setup events. This is like a kind of a weird like jQuery-ish pattern. And actually, this module could just do nothing until you call it. So we could say export a function that does these things, and you know what? They need to know a few things. They need a store because they need to know how to dispatch to a store. They need to know that message, so we can definitely bring in those actions. So let's bring in those actions. Set message. So we're reusing those definitions so that we don't have to update them if we ever want to change them. I'm going to leave these identifiers there for a moment. Now the store reference. We're creating the store over here. It's not made until this point. So we don't want to just like require this and call it. We want to make sure, first of all, that it happens after the store has been made. And rather than have just like a store that's like globally available, I'd rather say, like, I'm going to give you a store when I'm ready for you to operate, and I want you to use that store to create your shit. That way it's sort of injected. This is good because, one, it makes it easier to test. If you want to test this function, you can bring it into a module, and then you could invoke this yourself and pass in, like, a fake object. And then you could just make sure it did the right thing. It also just gets things out of global scope so people don't fuck with it. So we got this setup events. It's a function. Let's bring it in. I'm just going to call it setup events. Require it in from source setup events. And then once we have our store, we can call it and hand in the store. And now there is a problem because in my setup events I'm using that little helper. This is kind of silly because this is just because of where, it's just because I hate writing document.query selectors so many damn times. This is not available here. These are all bundles now. They're all modules now. So like they're inside their own scopes. Before this was all like fuck it global because we were in a browser and we knew we were in a browser. But now this stuff is being like compiled. It's actually being bundled together into a new JavaScript file. So it's all within its own scope. There's no more global, automatic global bullshit. So like these things are not available on global anymore unless we make them. So with that in mind, these things, these helpers, they're not in this scope. They don't exist over here. So I mean, this is just kind of like a thing that a problem I created. So that fixes it for now. I'm just going to paste these because I'm not going to like pull them out into a helper. This is just something that wouldn't exist in most circumstances, so I'm going to avoid creating a contrived answer to it at the moment. All right, so now we got events. They're being injected. Because they're a module, it's easy to inject them with something. So they have a reference to the store that I give them. It's not global, and they can I could test this pretty easily if I wanted to pull that out. What time is it? I'll tell you what, this is all working pretty well. I'm gonna actually, how could we test this? Well, we'd have to like extrapolate the buttons too because they're still accessing something that's kind of global. These buttons. So I guess I'll leave that alone for the moment. Section updaters. These things are kind of like our components. We could pull those out into their own modules if we wanted to. This is sort of like a startup script for now. Well, anyway, I think like pulling out reducers is pretty evident why you might want to use modules. Parcel or Webpack or whatever enables you to use the modules like that. There is a whole syntax called imports, which imports are not a straight up, they're a substitute for using require. they are different. They have different syntax, and they are different underneath the hood. I can show you real quick how you would replace these with imports, just to show you like the equivalence. So this line would become import Redux from Redux. I believe they expose a namespace like that. Oop, no they don't. It would be, we use create store, right? And we use combine reducers. And then we don't need to say Redux dots anymore. So imports are for ES6 modules. And this is basically like it looks like. You pull the pieces you want off of this object. So it's much more common in requiring world to sort of pull off the namespace and access it, Redux dot thing. The import world is much more common to do this. And in the ES6 version of Redux, because this could be the ES5 version of their source code, they probably don't expose their namespace as an export because you just grab the pieces you want. And I'm gonna shortchange and hand wave a little bit. One of the big reasons that this difference exists is because requires are evaluated at runtime when they are encountered in the code. Import statements can be statically evaluated. This is, yeah, some people might be, what the fuck, I don't follow. So it's kind of weird. Let me see if I can articulate a little bit better. Imports, some bundlers can look at imports, like this import, and they can say, look, there's other things in there, like bind action creators, but before I even go about compiling shit, I can read this import statement and I can see you only want these two functions, so I'm not going to bring in the code for this one. Like by statically analyzing the import statements, your bundlers, your compilers, if they're good ones, they know I'm not going to bring in the source code for bind action creators. I don't need it. Like you only wanted these two. Like I can tree shake, so to speak. I can actually, is it considered tree shaking? I don't know. I can optimize and I can leave out the code that you did not explicitly declare in your import statement. Require, because it's done during runtime, and a lot of times it's the whole module, I can't leave out any code because somewhere down the line you might say redux dot bind action creators. This is, or you might require a module later on in the code. Like I can't make those calls. So imports have some different restrictions on them, but they also have benefits, and that it comes largely from this difference in like requires are done during runtime. Which means I could require Redux like inside of a function. I could say require Redux and like just bring in a whole library only when that function gets called, which is neat and powerful. Also could be fucking terrible because requires are synchronous. They block the code from running until they finish. So if you bring in something gigantic, holy shit, that's dangerous. Imports are not. If I put an import statement down here, like my IDE is probably going to bitch at me, but it doesn't actually happen at that point. It gets hoisted. They will all actually be statically analyzed during compile time, and they will all be like brought in ahead. So there's differences there. The syntax looks similar, but there are also nuances to that. So like these, converting these into imports, going back, would just be a matter of basically doing this, and they will work pretty much the exact same. And notice like on the modules that we're bringing in, I wrote them like module.exports, the standard old school way, but import kind of works with them. A lot of the compilers like have this compatibility. They understand this mixing of the two forms, and so it's fine. So you can see import from and the requires. If you want to export the new way, It's not that crazy. You could just do export like that. Still the same. These are what's called named exports. There's also default exports. I don't want to get into them because it's a whole other thing that's a pile of fun. I'll say it's a pile of fun. But yeah, so that's the way you can do imports, modules, requires, and all that bullshit. I think I'm going to stop there for now and go into some other stuff some other time. Go play some video games. If you have any feedback, tweet me or whatever the hell people do, or message me or whatever, and maybe give me topics if you want me to go over something, and maybe I'll do them. Otherwise, I'll probably keep fucking with this goofy project until it becomes something terrible and an abomination. Have a good day.